Now we're going to work on creating a cycle which will keep track of the overall cycle of the character so that later we can decide which feet should be moving at what times. So to do this, we're going to create a new function and we're going to call this CalculateCycle. So we're going to click the plus icon on the function section, call it CalculateCycle, and compile and save because we've created a new function and that can just avoid some problems and crashing. And once again, we're going to separate the entry node from the return node. And what we need to do first is create our cycle variable. So in the variables section, we click the plus icon, and I'm going to call this master cycle %. And instead of it being a Boolean, we're going to set that to a float value, compile and save. And I'm calling this master cycle %, but it's actually a factor that goes from between 0 and 1. But I like to call it a percent just to keep track of what the numbers represent. So master cycle % should be a number that goes from 0 to 1, where 0 is the start of the cycle and 1 is the end. So all that we're going to do is drag in this master cycle % variable and choose set master cycle %. And we're going to connect this up to the execution path in this function and then connect it to the return node. And what we're going to do is take whatever the current master cycle % is and increase it by some value and then set it again. So each frame that it comes through, it will be increased by a certain value. So we'll drag in the master cycle % and do get master cycle %. Drag out from the value and do an add symbol, so search for add. And what we're going to do is add the time that has passed since this control rig was last updated. So once again, that is the delta time. So we search for delta time and we're going to plug that into the B path of the add node. So if we plug this result into the master cycle % directly, it will keep updating the master cycle % at a rate of 1 second per second. However, it will do this in smaller increments. So if you're running at 100 FPS, the delta time within one update will be 0.01, and it will do that 100 times, and then over the course of a second, the total increase will be 1 second. But we don't want it to keep going above 1 second. We want it to cycle around. So after it goes to 1, it will come back down to 0 and start over again. So the way we're going to do that is using the modulo node. So if you drag out from the result and search for the % sign, you'll see modulo. And what this does is essentially, it takes this input number and then takes out all the multiples of B. And this result is whatever remains after it's taken out all the multiples. So let's just connect the result to the value. And what we'll see that it does is, let's say, for example, this calculation where we take the master cycle % and increase it, let's say the result of this is 1.5. If the result is 1.5 and we do modulo of 1, that will mean it takes out all of the 1s and just leaves us with 0.5 remaining. So anytime this value that's input to A goes greater than this number, it will subtract that entire number and it will essentially restart from 0. And just as an example, if we set this number to 5, then every time this number was greater than 5, it would subtract 5 and just return whatever's left. But we're going to leave that at 1 for now, because this is a percentage and we want it to go between numbers of 0 and 1. And later on, we're going to adjust this and make this a bit more advanced, where the cycle will increase the speed the faster the character's moving. So the legs will move faster when the character's moving fast, and also slower when the character's moving slower. But for now, we've got a simple timer which just cycles through between 0 and 1 at a rate of 1 cycle per second.